Welcome to the online video lecture series of the course Computer Organization and Architecture. In this module of this subject, we have talked about various input output devices or peripheral devices, and we have also seen how a particular device is used to perform the input or output operation. We have also talked about interface which are used to perform the intermediate operation between device and the processor. Means it is used to communicate to make a bridge between the input output or peripheral devices and the CPU or processor. Now, in the present lecture, we will discuss how this transformation operation will take place. The transformation operation between various components of the system. If two devices are or components are used for transformation or taking part of the communication, then how these two devices are synchronized to each other. So, in this lecture, we will talk about various types of communication, means how a data transfer will be synchronized or used to perform between any given two devices. So, how these devices are synchronized? There are various ways to synchronize devices which are taking part in communication. Now, first is asynchronous data transfer. There are basically two types of transformation, that is synchronous and asynchronous. So, in case of asynchronous data transfer, devices will have their own clock. There are two types of synchronization operation, means two devices which are taking part in communication, they can be synchronized in two ways. First is synchronous data transfer, second is asynchronous data transfer. In case of synchronous data transfer, both the devices are using common clock, means two devices which are communicating to each other or transferring the data from one device to another device, they can be synchronized using common clock. So, that type of data transfer will call as synchronous data transfer. And the second type of data transfer, where devices are using their own or own private clock, or they are using their own clocks. So, how these two devices or devices which are using their own clock, they can be synchronized. So, here programmers developed various methodology or protocols through which two devices can be synchronized, means one device is sending the data is called as source unit, or the second unit which is receiving the data is called as destination devices. So, source unit and destination unit will be synchronized using some protocol or some methods. So, there are basically two methods we will study in this course, that is strobe control and second is handshaking. So, in case of strobe control, you can see the control signal will be issued by one device, either it is source or destination. Source unit means data transfer is initiated by some unit, or transfer of data, the data is transferred by some unit called as source, and the data which is receiving by some unit called as receiver or destination. So, in case of strobe control, there is a signal called as control signal or strobe signal will be issued by either source device or destination device. So, if the device source unit is initiated the data transfer is initiated by the source unit, then it is called as source initiated, or the data transfer is initiated by destination unit, then it is called as destination initiated. So, in case of source initiated data transfer, you can see there are two devices, source unit and destination unit. So, this particular strobe signal will be issued by the source unit, because this is source initiated data transfer. So, first it will provide a data or called as valid data onto the channel called as data bus. So, first the source unit will enable the signal of data, that is valid data, then it will enable the source or strobe signal or control signal informing the destination that the data is going to be transmitted, you can receive the data. So, the strobe may be activated by either the source or destination unit. So, in this particular case, a strobe control signal will be issued by the source unit. So, in strobe controlled or strobe control methodology, only one control signal will be issued either by source unit or destination unit. So, if it is source unit, then strobe signal will be issued by the source unit. So, before sending the control signal, it will first provide the data, put the data onto the channel. Channel means data bus. So, first this signal will be enabled, then after few microsecond or after that, after enabling this data signal, the strobe signal will be generated. So, this signal is generated by the source unit and informing the destination now that you can receive the data, data is available onto the channel. Now, destination unit will receive the data, and after some time the data has been received by the destination. After that, source unit will disable the strobe signal. Now, the strobe signal is down. After that, the data which is already available onto the channel will be disabled by the source unit. So, this way strobe control methodology will work. In case of source initiated, the strobe signal will be generated by the source unit. Now, in case of destination initiated strobe for data transfer. So, in this case, destination unit is requesting for the data. So, that is why the strobe signal will be generated by the destination unit, because in this case, in a strobe control methodology, only one signal will be issued or only one control signal is issued. So, in this case, the strobe signal is generated by the destination unit requesting for the data to inform the source unit that please provide the data. So, destination is requesting for the data to the source by informing or sending the strobe signal. So, that is why this strobe signal will be enabled before the data valid signal or data available on the channel. So, first the strobe signal will be high, then source unit will put the data which is a valid data onto the channel or issue the valid data signal informing the destination that you can receive the data, and after some time this signal will be disabled, or you can see the strobe signal, once the data is received by the destination unit, the strobe request signal or strobe control signal will be disabled by the destination unit, and immediately after that the data will be disabled or data signal will be disabled. So, in this case you can see the control signal is used to synchronize both the devices, source and destination. This is the method of asynchronous data transfer using strobe control. But in both the cases, in case of source initiated and destination initiated, there is one major drawback in this particular methodology, that is the source unit will never know whether the data has been received completely by the destination unit, yes or no. Means source unit will never be informed that the data which has been transferred by the source unit onto the channel or available on the channel, that is received completely by the destination unit. So, that is the major drawback of this strobe control methodology. Now, in case of next methodology, that is handshaking methodology or handshaking protocol, in this particular case both the units are properly informed. So, that is why this is two control signal methodology. In this case both the devices are properly informed. Two control signals are issued either in case of source initiated or destination initiated. So, let us talk about source initiated handshaking protocol. So, here both the devices are properly informed, means they are handshake manner, they are synchronized using handshake and reply message or reply signal. So, that is why handshake and reply signal are used to inform each other, to inform both the devices. Now, you can see there are two signals basically issued by the source and destination, that is data valid and data accepted. So, in case of source initiated, you can see the diagram of source initiated protocol or source initiated handshaking protocol. The steps you can see written here. So, in source initiated, source unit are written here, steps corresponding to source unit are written here, and steps corresponding to destination unit are written here. So, you can see here source unit first plays the data on the bus, because it is source initiated. So, initiation will take place by the source unit. It will first provide the data onto the channel. You can see here the valid data is issued by the source unit. Immediately this signal has been issued, that is that informs the destination that you can receive the data, that is valid data signal. So, both these signals are parallelly enabled by the source unit, so that source unit can receive the data which is available on the channel. This is the information given by the source unit. Now, destination unit will receive the data. It will take some time, and once the data is accepted. So, that is why these arrows shows first data bus signal is enabled, then this data valid signal is enabled by the source, informing the destination to receive the data. Then destination unit will receive the data, and once the data transfer is over or completed, the destination unit will inform the source unit that I have accepted the data completely or successfully. So, that is why this signal data accepted will be generated or issued by the destination unit, informing the source unit that I have received or the data transfer is over, the data successfully received by the destination. So, once the data accepted signal is enabled, immediately after that the valid data corresponding to that valid data, the data signal will be disabled by the source unit, because it is handshake protocol. Both the devices are properly informed to each other, right. So, in this case both the devices are aware that data transformation operation is successfully over or data is completely received by the destination, which is written here. You can see all these steps. First the source unit will place the data on the bus, then destination unit will accept the data from the bus, enable data accepted, and after that once the data is over or once the data is received by the destination unit, disable data valid or invalidate data bus, this invalidate the data bus, and then after that once the data valid or data signal is disabled by the source unit, then data accepted signal which is issued by the destination unit will be disabled here. So, that is why it is written here, disable the data accepted, ready to accept data. Initial case means it is initialized or reset in the original position. Now, in case of destination initiation, the request or signal will be issued first by the destination requesting for the data. So, in this case you can say the destination unit will first generate the signal that is ready for data. It is requesting, destination unit is requesting for the data. So, that is why this control signal will be issued by the destination unit, informing the source unit that please provide the data or please put the data so that I can receive the data. So, that is why ready to accept or ready for data signal is generated priorly to the other signals of the destination unit. Now, you can see steps written here, all these steps which are used in handshaking, destination initiated transfer corresponding to destination initiated transfer, all these steps are written here. Now, in case of this destination initiated, first the destination unit is requesting for the data. So, it will issue ready for data. Ready for data means informing the source please provide the data. So, this signal will be enabled by the destination unit prior to other signals. So, immediately after that it will put the data or which is valid data onto the channel, then it will enable the valid data, this particular line valid data signal informing the destination. Now, you can receive the data. So, that is why these two signals are issued or enabled by the destination unit, source unit. And after successful transformation or successfully receive the data by the destination unit, it will disable the ready for data, informing the source that I have accepted the data or I have received the data successfully. Now, you can disable all the lines or data lines. So, once the receive for data signal is disabled by the destination unit, inform the source that I have received. After that the data valid signal and corresponding data signal will be disabled by the source unit. So, you can see the steps corresponding to this particular methodology is written here. First, destination unit will generate the ready to accept the data or enable ready for data signal, and after that source unit will place the valid data onto the channel, and corresponding to that data valid signal will be enabled, and after acceptance of the data successfully, accept data from the bus, disable the ready for data. This signal will be disabled by the destination unit, and immediately after that other signals which are issued or enabled by the source unit will be disabled. So, this way both the devices are again informed to each other. So, it is a request and acknowledgement type of protocol where both the devices are properly informed. Now, next is asynchronous serial transfer. So, how this transformation operation will take place? There are two types of transformation as we have seen in first module, that is serial transformation and parallel transformation. So, in case of register transformation, in most of the cases, in case of register transformation, there is a parallel type of or parallel transformation will take place. Data transfer will be in parallel mode if we are taking two devices, a type of register. But the device like peripheral device or input output device, in most of the input output device case, the data transfer will be a type of serial transformation. In case of serial transformation, the synchronization operation will take place, or synchronous or asynchronous synchronization of type of protocols we have to study. So, serial transformation will be a type of synchronous or asynchronous. So, in this lecture we will talk about serial asynchronous serial transformation, where both the devices are using their own clock. So, in case of serial transformation, as we have seen, bits are serially one by one are transmitted from one device to another device. So, we need a shift register in that case, which can shift one bit at a time. So, what are the transmission rule we need to understand in case of asynchronous serial transformation? So, we have to see the information character and some encrypted bit or some bits we have to attach with each information, so that both the devices are properly informed. So, as we have seen handshaking protocol, how the devices are informed to each other in case of data transfer. So, using that methodology, we have to append some extra bit or some encoded bit with the character bit or information bits. So, in this case, we need to understand what is the transmission rule. The first is, when a character is not being sent, the line is kept in the one state, means they are the line will be on higher state, and the initiation of a character transmission is detected from the start bit, means we have to append some bit called as start bit, that we will see later. and it is always a 0 bit. So, start bit is 0 bit. So, that high state line will go down or will reach to the low state, informing the destination unit that the information or the message is going to be read by. Now, you can read the message. Now, message bits or information bits are starting. So, 0 or start bit is attached to each character bit. Next rule is the character bits always follow the start bit, obviously. So, at the start of the character or information bit, we have to attach some 0 bit or start bit. Now, next, after the last bit of the character is transmitted, a stop bit is detected. So, as we know, when there is no transformation or no data is available on the channel, the line will be in one state or higher state. So, when the message has been read by the destination unit, so how next character will be informed? To synchronize or to distinguish two characters separately, we have to add one more bit, that is stop bit. So, which tries to make the line at the high stage, which lets the line at high stage. So, that is why stop bits are also attached with the each character or information bits. So, 2 stop bits we will attach. Now, you can see in this diagram, suppose we have to send or the source unit wants to send some information bit of 8 bit. So, these are information bits. From this one to this one, these are information bit or character, which needs to be transferred from one place to another place. So, as per this protocol, asynchronous serial transfer, we have to attach one start bit here, that is 0, because initially the line was at higher state or one state. So, to let this state at the 0 state or low state, we have to attach start bit, informing the destination unit that you can start the information now. So, that is why 0 is attached before the information or character bits. Now, after 0, you can see there are 8 bits of information in that particular character, and after that, once the information is over, to inform the destination the message is over or information is over, or to become the line at higher state, these 2 stop bits are also attached. So, this way both the devices will be synchronized. So, we have to add 0 as a start bit and 1 as a stop bits. Let us see one more example here. Suppose there are 10 characters are to be transmitted and the speed of transfer is 10 character per second. So, which is written here 10 characters per second, and each transmitted character consists of start bit, 8 information bit and 2 stop bit. So, what is the length of this character? 8 plus 1 plus 2, that is 11. So, 11 bits are transmitted. So, 11 bits are transmitted means 1 bit for start bit, 8 bit for character bits and 2 bits for stop bits. So, what is the length? That is 11 bits are transmitted in one character. So, what is the clock pulse or how much time it will take to transmit 1 bit? So, 1 upon 10, because 10 characters per second it can transfer. So, 1 upon 10 for 1 bit it will take 0.1 second. So, this is for 1 character, or 11 bits can be transmitted in 0.1 second. We can also calculate what is the time to transfer 1 bit. So, 0.1 for 1 character, or you can say 11 bits can be transmitted in 0.1 second. So, question will be asked, what is the time taken by the device or channel to transmit 1 bit? So, 0.1 upon 11, that will come as 9.09 millisecond. So, this way we can calculate the numerical problem also. for transmitting the 1 bit or 1 character. This phenomenon is also called as baud. So, there are 10 characters per second transmission rate given in this particular problem, and the size of each character is 11 bits. So, this will come as 110 baud. So, this is called as baud, because 110 number of bits we are transmitting in 1 second. So, total number of bits which are transmitted in 1 second will come as 110, because 10 characters per second and each character is having 11 bits. So, this will come as 110 baud. So, this asynchronous communication interface, in this case we try to understand this is an interface, and this will work as a transmitter as well as receiver. So, we have also talked about what is the role of interface and what is the circuitry used in case of peripheral devices. Here you can see this will work as a transmitter as well as receiver. When CPU wants to transmit something, so this particular register will be used, and when some data is received by the processor from peripheral devices, then receive register will be used, and status register is basically used to check the flag conditions, and control register basically used to issue various control commands for reading and writing. So, this is the table used for this particular circuit. How this device or interface will work as an as a transmitter or as a receiver. So, these signals are used to work with this device. So, these are the explanation of various components which are used in this interface. You can see these are the various components. So, transmitter register basically use accept a data byte through the data bus from CPU and transferred to a shift register as shown here. This is shift register when the data is transmitted by the CPU, that will go to the shift register to shift one bit at a time to shift the character in each second or in each clock pulse. And when this device is working as a receiver, receives serial information into another shift register, and complete data byte is sent to the receiver register. And status register basically used to check the IO flags and for recording errors. And control register define baud rate, number of bits in each character, whether to generate and check parity and number of stop bits. So, these are the various components used in asynchronous communication or asynchronous serial transformation. So, this way we have seen what is the role of asynchronous data transfer. That is all about this lecture. Thank you.